The clock on your wall is not measuring anything. Its hands sweep, its seconds tick. And according to the deepest equation physics has ever written about the universe as a whole, there is nothing out there for it to measure. No flow, no moving now. The master equation of the cosmos contains no time at all. Tonight, a formula its own discoverer cursed, a warmth hiding in empty space, and a clock that costs 1 billion times more to read than to run. Look closer at the second hand. Watch it sweep. Right now, wherever you are, something in the room is keeping time. A wall clock, a phone, the watch on your wrist, and everything you believe about reality is riding on what that sweep represents. You believe it is tracking something, that beneath the ticking there is a current, a universal river of moments, flowing out of a fixed past, through a vivid now, into an open future, carrying you and the coffee cooling beside you, and every galaxy in the sky along with it, all together, all at the same rate. That belief sits so deep it does not feel like a belief. It feels like the precondition for anything at all. And tonight is the story of the physicists who followed our two best theories of reality down to the place where they meet, and found, waiting at the bottom, an equation in which that river simply does not appear. Not a slower river, not a stranger river, no river. And it is the story of the proposal built on top of that absence, a hypothesis called thermal time, published by a physicist and a mathematician in 1994, which says the flow you feel so vividly was never a feature of the universe at all. It is a feature of you, of warmth, of statistics, of how little of the world a creature like us can actually see. The claim sounds like it belongs in philosophy. It runs on some of the hardest mathematics in physics. It explains real temperatures measured in real laboratories, and it has never once been contradicted by experiment, though, as we will see with complete honesty, neither has its opposite. Hold on to the second hand. By the end of tonight, you will know exactly what physics can and cannot say about what it is doing, and you will meet the one discovery that would settle the question forever. Before anything else, be precise about what is actually at stake, because time hides 3 different claims inside one small word, and the whole night depends on keeping them apart. Claim 1. Things change. Nobody disputes that. Even calling it a claim feels absurd. Claim 2. Change has a direction. Eggs scramble and never unscramble. Smoke disperses and never regathers. That is the arrow of time, and this channel has spent whole evenings inside it. Tonight it plays only a supporting role. Claim 3, the one on trial tonight, that there is a flow, a moving present, a now that is a real, physical thing, the same for the whole universe, sliding forward at 1 second per second, converting future into past as it goes. Your instincts bundle all 3 claims together into one obvious package. Physics, it turns out, can buy the first 2 at full price, and has spent 60 years discovering that nobody can find the third one anywhere in the equations. Where would you look for it? Start with the theories we trust most. Quantum mechanics, on its own, keeps time as a parameter, the little t in the equations, a bookkeeping label supplied from outside the system, read off a laboratory clock that the theory itself never describes. General relativity is stranger. It welds time to space, lets it stretch and tilt, and, crucially, refuses to single out any universal present. 2 observers moving differently slice the universe into now differently, and relativity declares both slicings equally valid, which already leaves the idea of one cosmic flowing moment mortally wounded. But each theory alone still lets you keep some version of a clock in the story. The crisis comes when you force the 2 theories to merge, when you ask for the quantum mechanics of space-time itself. Because then the clock has to come from inside the system. There is no outside left to keep time from. The universe, described whole, has no wall for a clock to hang on. And in 1967, a physicist wrote down what happens when you do it anyway. His name was wheeler-dewitt, and the paper he published that year, the first of a monumental trilogy on the quantum theory of gravity, contains the equation this entire night orbits. The recipe he followed was, in outline, the standard one physics had used successfully everywhere else. Take the classical theory, Einstein's general relativity. Identify its Hamiltonian, the mathematical object that generates evolution in time. Promote everything to quantum operators. Write down the Schrödinger-style equation and solve for the wave function, in this case, the wave function of the entire universe, a single quantum state describing every possible three-dimensional geometry of space. DeWitt turned the crank, and general relativity, because it treats time as just another flexible coordinate with no preferred cosmic clock, pushed back in the strangest possible way. Its Hamiltonian is what physicists call a constraint. Instead of generating evolution, it is required to vanish. The equation that came out is the night's first equation, and it may be the shortest sentence of mathematics with the largest implication in all of science. Before the symbols, here is what it says in words. The total energy operator of the universe, acting on the wave function of the universe, gives exactly nothing. The equation reads h hat psi equals 0. H hat is the Hamiltonian of everything. Psi is the quantum state of everything, and 0 is 0. Feel what is missing from that equation, because its power is entirely in an absence. The Schrödinger equation you may have seen, the workhorse of ordinary quantum mechanics, says that the energy operator acting on a state equals a rate of change in time, IH bar d by dt. There is a little t in it, things evolve. In the Wheeler-DeWitt equation, the right-hand side is not a rate of change of anything. It is 0. No t appears, not hidden, not disguised, simply not there. Taken at face value, the equation says the quantum state of the universe does not evolve. It does not tick from configuration to configuration, it sits. Every possibility, every geometry, every history, encoded in one stationary mathematical object about which the equation permits exactly one temporal statement. Nothing happens. As the cosmologist George Ellis has spelled out the face value reading, by the ordinary rules, the state is time independent. Time does not pass, the universe just is. That is not a mystic talking. That is the arithmetic of our most conservative attempt to combine the two best-tested theories in history. The physicists closest to the equation trusted it least, and their discomfort is worth savouring because it tells you how seriously they took it. John Wheeler, DeWitt's collaborator in all but name, the man who badgered him into the problem, grandly called it the Einstein-Schrödinger equation. DeWitt himself, by Carlo Rovelli's account, preferred a different name, that damn equation. He never hid his unhappiness with the thing he had signed, and decades later, Rovelli, who built a career on taking it seriously, described it in print with brutal candour. It is a strange equation, full of nasty features. Strictly speaking, it is not even well defined. And yet, he added, there is no time variable in it, a puzzling feature for an equation with the ambition to govern quantum spacetime, one that has raised endless confusion and a debate about the nature of time that has never ended. Keep both halves of that verdict. The equation is mathematically treacherous, ill-defined at its edges, plagued by a probability structure that resists interpretation, an equation physicists handle with tongs. And the one feature every reading agrees on is the missing t. Whatever the final quantum theory of gravity turns out to be, this much has proven stubborn across every approach. When you describe the universe whole, the time variable you were expecting simply fails to show up for work. Now, an honest telling has to give the other side its best shot immediately, so here it is. One school of physicists looks at h hat psi equals 0 and says, this is not a revelation about reality. This is a symptom of asking a malformed question. Time has not vanished, they argue. It is hiding inside the wave function, and with the right mathematical surgery, you can split the Hamiltonian, pull a clock-like piece out of the universe's own contents, and recover an ordinary Schrödinger equation where things evolve with respect to that internal clock. On this reading, the equation is a bookkeeping puzzle, not a metaphysical bombshell. It is a respectable position. Versions of it are worked out in detail in the technical literature. And notice what even this deflationary reading concedes. The time that gets recovered is not a river running underneath the universe. It is a relationship between pieces of the universe, this thing changing relative to that thing. Even the school that rescues time rescues only relational time. The cosmic river, the flowing now, the same everywhere, carrying everything, stays gone on every reading. The debate is over what replaces it. And be careful not to inflate what the equation can carry, because its pathologies are real and they cut in every direction. What would it even mean to test h hat psi equals 0? The equation's solutions resist the usual quantum interpretation. The mathematical structure that normally turns a wave function into probabilities fails to be positive here, so the theory cannot straightforwardly say how likely anything is, which for a physical theory is close to not speaking at all. Its ingredients are formally ill-defined in ways specialists have battled for half a century. Is such an equation a deep truth in rough clothing, or a signpost that the whole approach took a wrong turn at the door? Physicists of the first rank sit on both sides. What no one disputes is the shape of the lesson. Every honest attempt to write quantum rules for the entire universe keeps producing descriptions in which time is demoted, from master variable to something that must be recovered, explained, or built. The pattern survives the pathologies. That is what makes it a clue rather than an accident. Pause here, because this deserves a moment of ordinary human honesty before the story goes further down. There is something almost offensive about the claim on the table. You have never experienced a timeless moment in your life. The one thing every conscious second has in common is that it flows into the next. A physics that says the fundamental description contains no flow is asking you to believe that the single most universal feature of your existence is, at bottom, not a feature of existence. Every instinct says the equations must be missing something. And here is what makes tonight genuinely interesting rather than merely provocative. Some of the best physicists alive agree with your instinct. We will meet them, and their arguments are serious. But before you side with them, you should see just how far the timeless picture can go. Because it does not stop at removing the river. It offers to explain, mechanically, precisely, why a creature living in a riverless world would feel the current anyway. And the explanation runs through the least likely door in all of physics. Not through clocks, through heat. If you find value in these long walks to the bottom of a question, consider subscribing. It helps these deep dives reach more curious minds. To see why heat is the door, we first have to go all the way down, to the floor of reality, where space itself comes apart into pieces. Because the timeless equation was only the beginning. When the program DeWitt started was carried to its modern form, it produced a full quantum theory of the fabric of space, and a picture of the world's foundations so still, so granular, and so strange that the missing river becomes almost the least of it. What does space look like when you magnify it 100 billion times past the atom? It stops looking like a stage. It starts looking like a net. The program is called Loop Quantum Gravity. Carlo Rovelli is one of its founders, along with Smolin and Abhay Ashtekar. And its central result sounds like a category mistake until the mathematics forces it on you. Space is not smooth, and space is not infinitely divisible. Area comes in indivisible quanta. Volume comes in indivisible quanta. At the deepest level, the quantum state of space is an object called a spin network. A graph, a web of edges and nodes, with a number attached to each edge and each node. An edge's number fixes a quantum of area. A node's number fixes a quantum of volume, and that is all there is. No coordinates underneath, no grid the network is drawn on. The network is not a structure sitting in space. The network is space, and asking what it is embedded in is exactly the mistake, as Rovelli puts it. Spin networks are excitations of space, not in space. Reality's flaw, in this picture, is a combinatorial web of pure adjacency. Which regions touch which? Woven at a scale so small it barely fits in the mind. The Planck length, 1.6 times 10 to the minus 35 meters. 100 billion times smaller than a proton. To account for the area of a single sheet of paper, the theory needs roughly 10 to the 68 threads of the network puncturing the page. A 1 followed by 68 zeros, a number vastly larger than every star, planet, and grain of sand in the observable universe combined for one page. Does the theory earn such extravagance? It has receipts worth naming. When loop quantum gravity counts the quantum states of a black hole's horizon, threads puncturing the horizon's surface, each carrying its pinch of area, the count reproduces the Bekenstein-Hawking entropy, the same area law that every serious approach to quantum gravity must hit. The matching fixes the theory's one free dial, a dimensionless constant called the Barbero-Immersi parameter, tuned to roughly 0.2375. File that number away with an honest asterisk we will cache later. A constant fixed by matching, not predicted from first principles, is a strength and an embarrassment at once, and physicists on all sides know it. But tonight's business with the spin network is not its entropy bookkeeping. It is a simpler, stranger question. Look at the web. Look at the numbers on its edges and nodes. Now ask, where, in this fundamental description of space, is anything moving? Nothing is. The spin network is a static object, a state, a configuration, a frozen chord of geometry. And when the theory computes dynamics, how one network relates to another, it does so through structures called spin foams, which assign amplitudes connecting geometries. But here is the sentence that should stop you, quoted in substance from the field's own standard review literature. In this background-independent setting, there is no meaningful notion of a transition amplitude between states at different times, and no meaningful notion of unitary time evolution. Read that twice. The theory does not say evolution is complicated, or approximate, or hard to compute. It says the very concept, a state at one time becoming a state at a later time, has no fundamental meaning, because there is no fundamental time for later to refer to. The amplitudes relate geometries to geometries, full stop. Sequence, duration, flow, none of it appears in the foundation. If loop quantum gravity is even roughly right about the flaw of the world, then the flaw of the world is still. Not still like a paused film, which implies a projector waiting to resume. Still like a sculpture. Still like a mathematical fact. What does it mean that every second of your life has been hosted by something that does not, itself, do seconds? Sit with the vertigo of the scale mismatch, because the numbers here are their own kind of poetry. The Planck time, the natural tick of this frozen substrate, the time it takes light to cross one thread of the web, is 5.4 times 10 to the minus 44 seconds. Compare. One ordinary second contains so many Planck times that a second is closer, on the raw number line, to the age of the universe than to a single Planck tick. When you glance at your watch and a second passes, you are not near the foundation. You are further from it than the universe's whole history is from your heartbeat. Everything you have ever called an instant is, from the substrate's perspective, a geological era of stillness stacked on stillness. But now the objection you should be shouting. This cannot be the whole story, because things do change. The coffee cools, the clock sweeps. You are hearing these words in sequence, and no amount of frozen web mathematics makes that experience negotiable. If the foundation has no flow, then the flow you are living inside right now has to come from somewhere. It has to be manufactured, somewhere between the timeless floor and the ticking kitchen. Where? This is the exact cliff edge where, in 1994, a physicist and a mathematician made the strangest proposal in the modern physics of time. The physicist was Rovelli, the mathematician was Alain, a Fields medalist, one of the deepest algebraists alive. And their answer, the thermal time hypothesis, locates the origin of time's flow in the last place intuition would ever look. Not in mechanics, not in geometry, in temperature, in the humble, kitchen-grade physics of heat. To understand why anyone would look there, you need two more pieces of the puzzle, and they must come in order. The first is old. The wound Relativity dealt the universal present back in 1905, which most people have heard as a slogan and almost nobody has felt as an argument. Tonight you will feel it. The second was found in 1930 by two physicists who caught heat doing something in a gravitational field that heat has no business doing. Before the story can go forward, it owes you the full account of an earlier wound, the one this night keeps calling mortal. The claim was made in passing near the beginning. Relativity already killed the universal now, back in 1905. It is time to see the body, because most people have heard the slogan without ever feeling the argument. And the argument is the foundation everything tonight stands on. What does it actually take to say two events happen at the same time? Not roughly, exactly. Say a light flickers in your kitchen, and far away, a wave breaks on a shore of the Southern Ocean. What fact about the universe makes those two events simultaneous, parts of the same single now, rather than one before the other? You have never needed to ask, because daily life supplies an easy answer. Everything you see happening now is now. But light takes time to travel, so what you see is always slightly stale. The question is about when things really happen, out there, independent of the delay in the news reaching you. Einstein's 1905 insight was that once you correct for the light delay honestly, the answer depends on how you are moving. Two observers drifting past each other, you at your table, a traveler passing at speed, performing identical, flawless procedures to establish which distant events are simultaneous with this instant, get different lists. Not because either erred, because the universe contains no fact of the matter that could make one list right and the other wrong. Simultaneity is not discovered. It is a bookkeeping convention, tied to a state of motion, no more absolute than left and right. Feel how deep the blade goes with the standard, staggering example. Stand up and walk across your room, a stroll 1 meter per second. As you do, your slice of what is happening right now across the universe tilts. For nearby things, the tilt is nothing. But simultaneity tilts with distance, and the universe is deep. For a galaxy 2.5 million light-years away, the gentle act of walking one direction rather than the other swings your now at that galaxy by roughly a day. Turn around, and events there that your bookkeeping called already settled become, on the new bookkeeping, not yet occurred. A pedestrian, by strolling, refiles a day of a galaxy's history between the done and the pending. Nothing physical changes out there, of course. No signal, no influence. The tilt is in the accounting, but that is precisely the point. If which distant events are past and which are future can be refiled by walking speed, then the past and the future cannot be absolute categories of the universe. They are perspectives. Philosophers sharpened this into the block universe argument, associated with Reitdijk and Putnam. Since every event is in somebody's legitimate, now, slice, and no slice is privileged, the democratic conclusion is that all events, at all times, are equally real. The cosmos becomes a single, complete, four-dimensional fact, with your birth and your final breath, and the last stars cooling all present in the block on equal footing, and the flowing now demoted to wherever consciousness happens to be reading. Relativity does not quite force that conclusion. Ellis will fight it later tonight, and you have already heard that his fight is serious. But relativity permits it fits it like a glove, and offers nothing whatsoever for the alternative to hold on to. What does it mean that the physics found in every GPS satellite, engineering, not philosophy, verified every time your phone finds a street, is the same physics that cannot locate the present moment anywhere in the universe? And notice what this does to the shape of tonight's mystery, because it sets the stakes for everything that follows. The Wheeler-DeWitt equation did not start the crisis of time. It inherited a crisis already 90 years old and drove it to the foundation. Relativity removed the universal now, but left each observer a perfectly good personal time. The proper time of your own world line, the seconds your own heart and watch agree on, sturdy and local and real. You could live with that. No cosmic river, fine, but at least a private stream per traveler. What the quantum gravity equations then did was reach down beneath even the private stream and report that at the foundation, no stream of any kind is required. Not universal, not personal, none. First, physics took away the one river everyone shared. Then it asked whether rivers were ever fundamental at all. That double demotion is the true starting point of the thermal time hypothesis. Because if nothing flows at the bottom, and yet your coffee demonstrably cools, the flow must be assembled somewhere in between. Where and out of what? Every road tonight leads through that gap. And the first landmark inside it, as promised, is heat. But heat carries its own scandal about direction, one that has been waiting since the 19th century, and tonight we'll need it on the table. Because the same statistical mechanics that explains why eggs scramble contains, buried in its founding theorem, a symmetry that should have made the explanation impossible. And the man who found the theorem spent his final years defending it against exactly that charge. Physics has been manufacturing time out of heat, in one sense or another, for 130 years. It has just never before proposed that the manufacture goes all the way down. In 1930, Richard Tolman and Paul-Ehrenfest published a calculation about the most domestic subject in physics, a column of gas sitting in a gravitational field, left alone until it reaches perfect thermal equilibrium. Every textbook before them would have said the outcome plainly. Equilibrium means one temperature throughout. That is practically the definition of the word. Tolman and Ehrenfest ran it through general relativity and found the textbooks wrong. At true equilibrium in a gravitational field, the temperature is not uniform. It is very slightly hotter at the bottom than at the top. Not because heat is still flowing downhill, but as the finished, settled, final state. The effect is tiny in any laboratory, but its meaning is enormous, and Tolman phrased it in 3 words that deserve their fame. Heat has weight. Thermal energy gravitates, so equilibrium itself bends around gravity. An idea Einstein had sniffed at as early as 1912 had become a theorem, and then it sat in the literature for 60 years. A beautiful oddity, an exam problem, a footnote. Nobody imagined it was a clue about the nature of time. Hold it in your hand. By tonight's end, it becomes one of the 2 or 3 load-bearing stones of the whole edifice. Before the abstraction arrives, anchor the connection between heat and time where you already live with it, because you do, daily, bodily, without ever naming it. Why does a hot pan cool at a rate you can predict? Why does everything warm, settle, relax, forget its history? The coffee losing the memory of its pouring, the bathwater losing the memory of the tap. Every thermal process you have ever touched is also a clock. Candles were clocks, water clocks were clocks, and your own body's slow chemistry is the clock you feel age by. Heat and time have been keeping each other's books since before physics existed. What does it mean that every culture on Earth, needing to measure duration, reached instinctively for processes that dissipate, burning, dripping, decaying, as if some part of us always knew the two were entangled? The 19th century made the ledger official. Thermodynamics is the only branch of classical physics whose laws care about time's direction at all. Tonight simply asks the question underneath. If warmth is where time's direction lives, and warmth is where time's rate can bend, could warmth be where time itself comes from? Because now we can open the door the last chapter promised, the door marked heat, and walk through what temperature actually is, down at the bottom. Here is the night's second equation, and unlike the first, this one has been in every statistical mechanics course for over a century. It describes a system in thermal equilibrium, a warm gas, a cooling coffee, anything settled at temperature T, and before the symbols, its meaning in words. The probability of finding the system in any given configuration falls off exponentially with that configuration's energy, and the temperature sets how fast. The equation reads, ρ equals e to the minus beta h. ρ is the statistical state, the full catalogue of probabilities. H is the energy. Beta is 1 over the temperature. That little formula, the Gibbs state, is the mathematical heart of the word warm. And look closely at its cast of characters because something is hiding in plain sight. The formula for being at temperature contains H, the Hamiltonian, the generator of time evolution, the very operator whose vanishing act in the Wheeler-DeWitt equation started this whole night. Written in the standard language of quantum mechanics, the parallel becomes almost eerie. Evolving a state through time uses e to the minus I ht over h bar. Being at equilibrium uses e to the minus beta h. Time evolution and temperature are the same mathematical expression, one with an imaginary number in the exponent, one without. Physicists had noticed this so-called Wick rotation for decades and mostly treated it as a computational trick, a cute coincidence of notation. Temperature looks like time runs sideways, imaginary time. Next problem. The thermal time hypothesis is what happens when two people decide it is not a coincidence, and then run the arrow backwards. Watch the inversion carefully, because it is the single most important move of the night. The traditional logic goes, first the universe has time. Then, given time, systems evolve. Then, among all the ways matter can arrange itself, some special states, the equilibrium ones, happen to be stable under that evolution. Time first, heat second. Equilibrium is defined by its stillness with respect to a pre-existing flow. Cons and Rovelli propose the exact reverse. Suppose there is no pre-existing flow, the Wheeler-DeWitt world, the frozen spin network world. Take as given only what a timeless universe can actually offer, the system's full catalogue of observables, and its statistical state, which configurations are how probable. That is all. No clock anywhere. Their claim, that is already enough. A statistical state, they argued, does not merely sit in time, it generates a time. From the state and the observables alone, with no temporal input whatsoever, mathematics manufactures a one-parameter flow, an ordering, a direction, a rate, and that manufactured flow, they proposed, is the thing you have been calling time all your life. Heat first, time second. The river does not carry the warmth is the river. Stated baldly like that, it sounds like a philosopher's conjuring trick. You cannot pull a flowing tea out of a static hat. Except that the hat is not empty, and this is where the Fields medalist enters the story. The mathematics of the trick had already existed for 25 years before the physics found it, discovered for completely unrelated reasons in the driest corner of operator theory. In the late 1960s, the Japanese mathematician Minoru Tomita, his work sharpened and published by Masamichi-Takesaki, proved a theorem about von Neumann algebras, the abstract structures that hold all the observables of a quantum system. The tomita-Takesaki theorem says, in essence, hand me an algebra of observables and one suitable state on it, and I will hand you back, for free, a canonical one-parameter flow, a mathematically inevitable way the algebra rotates into itself, generated by nothing but the pairing of state and algebra. The flow was never built for physics. It fell out of pure structure, an unavoidable byproduct, the way a shadow falls out of an object and a light source. Mathematicians called it the modular flow, filed it among their classification tools, and moved on. It took physics until 1994 to turn around and ask the obvious retrospective question. The universe's fundamental equations offer no time, and pure mathematics has been holding an unclaimed, automatically generated flow for decades. What if the second is the first? What if the modular flow is not a shadow of time, but its source? Here is the machinery, stated once, carefully, and then translated. The Knight's third equation is the modular flow itself. Before the symbols, it says that from a state and its algebra of observables, one builds a special operator called delta, and that operator, raised to imaginary powers, rotates every observable along a one-parameter path. The equation reads, alpha t of A equals delta to the minus it, A, delta to the it. A is any observable, any question you could ask the system. Alpha t of A is that same question, carried t steps along the flow. And delta, the modular operator, is manufactured directly from the state, from nothing but the statistical facts about which configurations are how probable. Translation: give the mathematics a frozen catalogue of probabilities, and it gives you back a conveyor belt. Every observable gets carried, in order, at a rate, in a direction. Nothing about clocks was put in. Something exactly like a clock comes out. If that were the whole result, it would be a curiosity. What elevates it to the center of tonight is the identity of the conveyor belt. When mathematical physicists in the late 1960s, Rudolf Haag and his collaborators among them, formulated the rigorous definition of thermal equilibrium, the KMS condition, something remarkable emerged. The modular flow generated by a thermal state satisfies exactly that condition. In plain words, the flow that mathematics automatically produces from a state is precisely the flow with respect to which that state is at perfect thermal equilibrium. The two structures, one from pure operator theory, one from the physics of heat, snap together like halves of a broken coin. Haag himself, one of the most careful minds in the foundations of quantum theory, called the discovery a beautiful example of pre-stabilized harmony between physics and mathematics. And notice what the harmony whispers. Temperature and time are not neighbors who happen to share a formula. At the level of rigorous structure, a thermal state and a time flow are two descriptions of one object. Every warm thing is, mathematically speaking, a clock. And there is a deeper layer still, the one Cons brought, and the reason the hypothesis needed a Fields medalist. You might worry, different states generate different flows, so has the proposal merely replaced one missing time with infinitely many optional times? Cons had proven, years earlier, a theorem that diffuses the worry with startling elegance. Any two states' modular flows differ only by what algebraists call an inner adjustment, a reshuffling within the algebra that leaves the overall pattern untouched. Strip that removable layer away, and every state generates the same underlying outer flow. The algebra of observables possesses, all by itself, one canonical intrinsic dynamics, before any state is chosen, before any physics is specified. As the Cons-Rovelli paper puts it, a von Neumann algebra is intrinsically a dynamical object. Let the strangeness of that reach you, the bare mathematical container of a quantum system's questions, nothing yet about energies, particles, or fields, already carries, woven into its abstract skeleton, a preferred one-parameter motion. On this view, asking why the universe has time is like asking why a circle has roundness. Structure this rich cannot help flowing. So, assemble the hypothesis in its final form, because after an hour of preparation, it now fits in 3 sentences. The universe, fundamentally, has no time. The wheeler-dewitt world, the spin network world, the sculpture. But we never see the universe fundamentally. We are small, coarse, warm creatures with access to a tiny bandful of observables, and the state we actually experience through that narrow window is a statistical thermal blur. And by tomita-takesaki, a thermal blur generates a flow. That flow, the modular flow of our restricted, ignorant, warm description of the world, is what we call time. The hypothesis even supplies the exchange rate. Physical time equals h bar times beta times the modular parameter. The conversion between the abstract flow and the seconds on your wall runs through the temperature. Time, on this proposal, is not the stage the universe performs on. It is an artifact of blur, the specific blur of creatures who cannot see the microstate. Rovelli would later compress it into one of the most quietly radical sentences in modern science writing. The difference between past and future refers only to our own blurred vision of the world. And then he asks the question that should be echoing in you by now. Is it really possible that a perception so vivid, so basic, so existential, depends on the fact that I cannot apprehend the world in all its minute detail? Extraordinary claims need receipts, so here are the two the hypothesis has actually produced, stated honestly at their real size. Receipt 1. Point the machinery at the actual universe. The cosmos is bathed in the cosmic microwave background, the 2.7 Kelvin afterglow filling every cubic meter of sky, the largest thermal state in existence. Feed that state into the thermal time machinery, ask what flow it generates, and out comes the standard cosmological time of the expanding universe, the very parameter cosmologists call the age of the cosmos, recovered rather than assumed. The 13.82 billion years since the beginning, on this reading, is not time that contained the radiation, it is time generated by the radiation. The sky is not in the clock, the sky is the clock. Receipt 2 closes tonight's oldest open loop. In 2011, Rovelli and Matteo Smerlach took the Tolman-Ehrenfest oddity from 1930, hotter at the bottom, at equilibrium, heat has weight, and showed it falls out of the thermal time hypothesis in one line. If temperature is the local ticking rate of thermal time, then where gravity slows time, deeper in the field, as relativity has proven to exquisite precision, the ticking runs slower, and the temperature must run correspondingly hotter to keep the same equilibrium flow. The 80-year-old footnote turns out to be the theory's signature. Temperature gradients tracking time dilation exactly, with no extra assumptions. 2 receipts. Neither is a smoking gun. Both phenomena have other derivations, but both are the sound a deep idea makes when it touches real physics and does not break. Translate the whole proposal back down to your kitchen one time before it faces its critics, because you deserve to hear the claim in the language of an ordinary evening. You are sitting with a cooling cup of coffee. The traditional story. Time passes and therefore the coffee cools. The thermal time story said plainly, there is no passing underneath. There is a vast, still quantum state, and you, a small warm subsystem, coupled to a few blurry averages of it. Out of that blur, mathematics mints an ordering. This configuration, then that one, then that one. And the minted ordering is the only passing there has ever been. The coffee does not cool because time flows. What you call time flowing is the name for the family of facts of which the coffee's cooling is one. Do you feel how the explanation inverts, like a glove pulled inside out? Nothing about the evening changes. The cup still cools at the same rate. Your watch still agrees with the kitchen clock. And yet the entire metaphysical spine of the scene has been replaced. What does it mean that 2 descriptions this different, a flowing river, a static state wearing a blur, can sit under the same cup of coffee and match every measurement you could ever make on it? That question is not rhetorical tonight. It is exactly the question the experiments have so far refused to answer. And yet, you can feel the objection building, and it is the right objection. Everything so far lives in mathematics and cosmology, comfortably far from your kitchen. If temperature and time are secretly one thing, should that identity not show up somewhere closer, somewhere a body could, at least in principle, feel it? It should. It does. There is a prediction sitting inside this circle of ideas, so strange that it sounds like a test invented to embarrass the theory. Take an observer holding a thermometer in a perfect vacuum. No matter, no radiation, nothing. The coldest emptiness physics can define, and have them accelerate. The identity of heat and time demands that the empty vacuum itself must turn warm in their hands. Not seem warm, be warm, real temperature, real excitations, from nothing but motion through nothingness. That prediction was derived in 1976. It carries the name of the physicist who found it, and the number attached to it is one of the most humbling in all of physics. Here is what it costs to feel 1 single degree of the vacuum's hidden warmth. The physicist is William Unruh, and the result, building on work by Stephen Fulling and Paul Davies, is the night's 4th and final equation, the shortest bridge ever built between motion and heat. Before the symbols, it says that an accelerating observer in perfect vacuum measures a real temperature proportional to their acceleration. The equation reads T equals h bar A divided by 2 pi c kb. The A is your acceleration. Everything else is a constant of nature. H bar from quantum mechanics, c from relativity, Boltzmann's kb from thermodynamics. 3 branches of physics, 1 per constant, meeting in a formula the size of a fortune cookie slip. Accelerate through nothing, and nothing acquires a temperature. Why would that be? The mechanism, loosely. The quantum vacuum is not empty, but a seething ground state of fields, and what counts as a particle in that sea depends on your state of motion. An accelerating observer slices the vacuum differently. Their horizon hides part of the field from them, their description blurs. And a blurred, restricted view of a pure state is, as tonight has drilled, a thermal state. The vacuum's warmth is ignorance made physical. The Unruh effect is the thermal time hypothesis's entire worldview compressed into a laboratory-sized statement. Restrict the observer, and temperature, with its flow, appears where neither existed. Now the number, because the number is the story. Solve the equation for the acceleration needed to feel 1 Kelvin, 1 single degree above absolute zero, still colder than any freezer on Earth. The answer? 2.4 times 10 to the 20 meters per second squared. 24 billion trillion times the gravity holding you in your chair. An acceleration that would take you from rest past the speed of light's neighborhood in a nanoseconds fraction, applied continuously, buys you 1 degree of vacuum warmth. Your morning commute, your fastest fighter jet, your most violent rocket launch, all of it registers vacuum temperatures of essentially 0, decimal points marching to the horizon before the first digit. This is why no thermometer has ever directly caught the vacuum glowing, and why the effect's experimental status must be reported honestly. It is a theoretical result, derived independently so many ways that almost no one doubts it, with tantalizing indirect support. Physicists at storage rings have long noted that circulating electrons refuse to polarize completely, as though warmed by exactly this effect, a reading proposed by John Bell himself with John Magna Linus. But a clean, direct detection remains beyond us. The identity of heat and time, if it holds, hides behind 20 orders of magnitude of acceleration. Nature agreed to the marriage and then set the dowry beyond any laboratory on Earth. The same identity has an astrophysical face you have met before on this channel. A black hole's surface gravity, run through the sister formula, gives the Hawking temperature, the faint quantum glow that makes black holes mortal. And the same brutal arithmetic applies. A 30 solar mass black hole glows at 2 billionths of 1 Kelvin, a signal drowned a billion times over by the 2.7 Kelvin microwave sky it sits in. The universe's deepest thermal secrets are all real, all derivable, and all whispered at volumes no instrument can hear. What does it mean that the strongest clues about the nature of time are the quietest signals in the cosmos? But the strangest entry in this family, the one that circles all the way back to a human life, came in 2003 from Rovelli and Pierre Martinetti, and it deserves to be told slowly. Every result so far required acceleration. Motion buys warmth. Martinetti and Rovelli asked about an observer who does not accelerate at all, someone simply born, living a finite span, and ending at rest in the vacuum the entire while. Such an observer never has access to the whole of spacetime. Their knowable world is a bounded diamond, the overlap of everything light could bring them after their beginning, with everything they could still signal before their end. A finite life is, geometrically, a diamond-shaped window on the universe. Run the thermal time machinery on the vacuum as seen through that window, a restricted, bounded, blurred view of a pure state, and out comes a temperature. The diamond temperature, non-zero, largest near the diamond's edges, present without any motion at all. Merely being finite, merely having a beginning and an end, is enough in this mathematics to make the vacuum glow faintly warm around you. The number is unmeasurably small for any human-scale diamond. No instrument will ever read it off a life. But sit with what the calculation is claiming. Warmth, and with it the ticking of thermal time, attaches not to the universe but to the frame of a bounded existence within it. The sculpture does not flow. A finite window onto the sculpture does. Pause on that, because it is as close as mathematical physics has ever come to a statement about mortality, and it earns one careful human paragraph. You did not choose the diamond. Its lower tip was set the moment you began. Its upper tip waits somewhere ahead. And according to this line of thought, the very warmth and passage that fill the inside of your window, the felt flow this entire night is about, are artifacts of the window having tips at all. An unbounded observer on this mathematics would feel no flow. Nothing would pass because nothing would be hidden. It is the finitude that makes the current. Whether that lands on you as bleak or as strangely consoling is not physics business. But do not let anyone tell you the equations of quantum gravity have nothing to say to an ordinary evening. This one followed you home. So the timeless picture stands assembled, receipts and all. A master equation with no T, a frozen web beneath space, a mathematical machine that mints time from warmth, a vacuum that heats for the accelerating and glows for the finite. It is elegant, rigorous, and, be honest with the scoreboard, still a minority research program resting on two enormous promissory notes. And now the night turns, as this channel always turns, to the people who think the whole beautiful edifice is standing on air. Their case does not begin with equations. It begins with the most stubborn fact in your possession. The second hand is sweeping right now, and you are watching it, and no theorem has ever explained an experience away by calling it a blur. The rebels include a founder of loop quantum gravity itself. The theory's own house is divided. A cosmologist who helped write the standard model of the universe, and a quantum physicist armed with a different kind of mathematics. They think time is real, all the way down. And their opening argument is aimed straight at the heart of everything you have heard tonight. Smolin helped build loop quantum gravity. He stood inside the timeless mathematics for decades, contributed some of its foundational results, and then, in a book published in 2013, whose title is its thesis, Time Reborn, declared the entire timeless conclusion a mistake. Not a small mistake. The mistake, in his telling, the deepest error in modern physics. His argument is worth hearing at full strength, because it does not quarrel with any equation tonight has shown you. It quarrels with what the equations were allowed to mean. Physics, Smolin observes, perfected a method over 4 centuries. Isolate a subsystem, a pendulum, a planet, a particle beam, stand outside it with a clock on the wall, and write timeless laws describing how the subsystem's configurations succeed one another. The method is glorious, and it works precisely because the physicist, the clock, and the rest of the universe remain outside the box being described. Now notice what the Wheeler-DeWitt equation is, that same method applied to a box with no outside, the whole universe, clock, physicist, and all, swallowed into the description. Smolin's charge is that this is not a bold extension but an illegal one, a category error he names the cosmological fallacy. Of course the time variable vanished, he says. You fed the formalism the one system from which the formalism's own external clock had been removed, and it returned an equation with no clock. That is not a discovery about reality, that is the method reporting its own boundary, and mistaking the report for metaphysics. On Smolin's view, time is not emergent but fundamental, the one thing that is truly universal, and it runs so deep that even the laws of physics themselves may evolve within it, which would explain, he argues, why the laws take the particular forms they do at this cosmic hour. You do not have to buy the whole program to feel the force of the opening move. Every timeless conclusion tonight came from equations. Smolin is asking who authorized those equations to govern the whole. George Ellis attacks from experience rather than method, and his standing makes the attack land. He is one of the great relativists alive, co-author with Stephen Hawking of the standard treatise on space-time structure. Ellis looks at the block universe reading of relativity, past, present and future all equally real, laid out whole, and points at the laboratory, the newsroom, the delivery ward. Things happen, Ellis insists. Outcomes that were genuinely open become genuinely fixed. A quantum measurement whose result did not exist at breakfast exists by lunch, permanently. His proposal, the evolving block universe, redraws the picture. The past is real and closed, a solid, ever-thickening block of settled fact. The future is not real yet, and the present is the growing edge, the surface where indeterminate possibility crystallizes into unchangeable history. Space-time, on this view, is not a finished sculpture. It is a sculpture still being carved, its cut face advancing. The dimension along which the block grows is time, and the growth is as real as anything in science. Where tonight's timeless theorists see our vivid now as statistical blur, Ellis sees their frozen block as an over-extrapolated diagram, and he has a barb for the whole tribe of formalism-first physics that this channel quotes with relish. Some of my colleagues, he said, seem to think their models trump reality. The third rebel digs beneath both, into the mathematics itself. Nicholas Gisin, the Geneva physicist whose Bell test experiments across lake and fiber made him a legend of quantum foundations, noticed that the timeless block has an unexamined accomplice, the real numbers. Classical physics assumes that the state of the world now is a set of real numbers, each with infinitely many decimal digits, all of them determinate. But an infinite string of determinate digits contains infinite information, and information, Gisin argues, is physical, and finite regions hold finite amounts. The unlimited decimal expansions, he says, are the hidden variables of classical mechanics, an infinitely detailed future smuggled into the present inside the digits, making determinism, and with it the finished block, true by notational fiat before physics even begins. Rebuild physics on intuitionist mathematics, where a number's digits are not all fixed in advance but come into being as a process, and the picture inverts. The present holds finite information, the far decimals of the future are genuinely not yet determined, and time's passage becomes the very process by which they become determined. Time, Gisin told an interviewer, is not unfolding like a movie in the cinema. It is really a creative unfolding. The future is open because it is, in the most literal mathematical sense, unwritten. And beyond the three grand alternatives, the thermal time hypothesis has taken precise technical fire on its own ground, and honesty requires the wounds be shown. Philosophers of physics have pressed three hard charges. First, circularity. Equilibrium is the concept the hypothesis builds time from. But can you even define equilibrium, critics like Eugene Chua ask, without already presupposing a dynamics, a flow with respect to which the state is stable? If yes, the construction stands. If no, the hypothesis manufactures time using parts labeled time, and the magic trick has a false bottom. Second, scope. The beautiful machinery runs on equilibrium states, and the actual universe is not at equilibrium. It is an expanding, radiating, gradient-riddled cascade. For generic non-equilibrium states, the modular flow exists, but its physical meaning grows murky, and no one has established that a universal thermal time can even be defined across a cosmos this messy. Third, the deepest cut from the philosopher Noel Swanson. Check the hypothesis against the one observer we actually are. For a finite lifetime diamond observer, Swanson showed, thermal time and ordinary proper time, the time your watch and your cells actually keep, do not in general converge. The modular flow fails to acquire the clean geometric meaning the hypothesis needs at exactly the human scale it was built to explain. Add the plainest gap of all. The cosmic thermal state ticks at 2.7 Kelvin, a signal your nervous system cannot register even in principle without a radio telescope. So whatever your vivid sense of passing moments is made of, the causal path from that faint sky glow to this feeling has never been traced. The hypothesis explains beautifully how a time flow could arise from warmth. It has not yet explained how your time arises from that warmth. Take your own pulse before the verdict, because by now you have picked a side whether you chose to or not. Perhaps the timeless mathematics thrilled you, and the rebels sound like nostalgia defending a doomed intuition. In which case, ask yourself honestly whether you would hold that position standing at a graveside, where the difference between the past is gone and the past is elsewhere in the block stops being academic. Or perhaps Smolin and Ellis and Gisin sound like sanity itself, in which case, ask what you make of the stubborn fact that nobody, in a century of trying, has found the flowing now in a single equation that works. Which loyalty runs deeper in you, to the mathematics that keeps working, or to the experience that keeps happening? There is no shame in either answer. There is only the discipline of noticing that you have one, and that the universe has not yet endorsed it. So the board stands even and refreshingly human. On one side, a timeless substrate with a mathematically gorgeous mechanism for minting the flow, bleeding from 3 technical wounds. On the other, 3 serious programs insisting the flow is real, each carrying philosophical commitments physics cannot yet cash either. What could break the symmetry? Not another argument, an experiment. And here the knight must turn to the only corner of this entire subject where anyone has actually done one, where a version of the timeless proposal was wheeled into a laboratory in Turin, built out of 2 particles of light and switched on. Because there is a second emergent time program tonight has only name-dropped, older than thermal time by a decade, and unlike everything else in this story, it has been demonstrated, in miniature with real photons on a real table. Its founding paper carries the most quietly outrageous title in the physics of time: Evolution Without Evolution. The paper appeared in 1983, 11 years before thermal time, and its authors are 2 names this channel keeps meeting at the deep ends of physics. Don Page, later the cartographer of black hole information's famous curve, and William Wootters, soon to co-prove the no-cloning theorem. Their question was diamond hard. If the wheeler-dewitt universe is globally static, what would living inside it actually be like? And their answer overturned the assumption hiding in the question. A frozen universe, they showed, does not look frozen from within, provided it contains entanglement. The construction is clean enough to state plainly. Split the universe's contents into 2 pieces. One small piece to serve as a clock, any system with a steadily shifting property, a rotating polarization, a swinging pendulum, anything. And the rest of the universe as everything else. Let the global state satisfy the timeless constraint exactly. Total energy 0, nothing evolving, the full wheeler-dewitt stillness. But let the clock piece and the rest be entangled, their states correlated, quantum mechanically laced together. Now ask the only question an inhabitant can ever actually ask. Not, what is the universe doing as absolute time passes? No inhabitant has ever had access to absolute time. The real question is always relational. What does the rest of the universe look like when the clock reads 3? And Page and Wootters proved that in a static, entangled universe, the answers to that relational question line up perfectly. Conditioned on clock reading 1, the rest is in state 1. Conditioned on reading 2, state 2. And the sequence of conditional states obeys, exactly, the Schrödinger equation. Evolution without evolution. Viewed from outside, if an outside existed, one frozen state, nothing happening, ever. Viewed from inside, by correlating yourself against the clock piece, ordinary dynamical physics, moments succeeding moments, governed by the usual law of motion. Time, in this picture, is not a river the universe floats down. Time is a pattern of correlations between one piece of a frozen whole and another, and dynamics is what that pattern feels like from inside. For 30 years this stayed a formal argument, troubled too by a technical objection from the relativist Karel Kuchaj about whether propagators built this way came out right, an objection later diffused by refined constructions from Rodolfo Gambini, Jorge Pullin and collaborators. Then, in 2013, a group in Turin led by Ekaterina Moreva did the thing that separates physics from philosophy. They built it. The universe on their optical table was tiny, 2 photons entangled in polarization. But the logic was the full page-wootters logic, exact and complete. 1 photon served as the clock. Its polarization rotated steadily as it traveled through a quartz plate, a genuine ticking hand made of light. The other photon was the rest of the universe, and the experimenters occupied in turn the only 2 standpoints the mechanism allows. Standpoint 1, the internal observer. Measure the clock photon, condition on its reading, and look at the partner. Result? The partner's state marched in step with the clock's reading. From inside, the 2-photon universe evolved obediently, dynamically, moment by relational moment. Standpoint 2, the external, outside the whole view a real cosmos would never offer, but a 2-photon cosmos does. Measure the joint state of both photons together, asking not what time is it inside, but what is the whole system's state, full stop. Result: a static state, no evolution. The identical pair of photons, the identical apparatus, the identical afternoon in Turin. Seen from within, a universe with time. Seen from without, a universe without it. The experiment settles nothing about our cosmos. It is a demonstration of consistency, not a discovery about the sky. But let its point land squarely. The universe evolves and the universe is static are not necessarily contradictory claims. They can be 2 descriptions of one entangled fact, differing only in where the describer stands. The most ancient dichotomy in the philosophy of time, being versus becoming, Parmenides versus Heraclitus, was, on one table in Turin, dissolved into a question of vantage. And notice who has quietly moved to the center of every version of this story. The clock. Not time, clocks. Physical systems that tick. The timeless programs all agree on this striking inversion. There is no time that clocks measure. There are only clocks. And time is the name we give to the web of correlations among them. Which raises a question almost too simple to sound scientific. If clocks are not passive readers of a cosmic flow, but the actual generators of temporal order, then what does it cost to be a clock? That question left philosophy and entered the laboratory in November of 2025, in a collaboration spanning Oxford, Vienna, and Dublin, and its answer is tonight's final number. The team, with Natalia Aries among its leaders, built one of the most elementary clocks possible. a double quantum dot, two adjacent traps for single electrons, ticking as electrons tunneled one by one, a nanoscale escapement counting its own quantum jumps. Thermodynamics already taught that every clock must dissipate. Each tick pays an entropy toll, order spent for order kept. No free timekeeping. But when the team measured the full budget of their clock, the ledger came back absurd and wonderful. The cost of running the clock, generating the ticks themselves, was minuscule. The overwhelming cost was reading it, amplifying each microscopic tick to a signal a macroscopic observer could register, consumed roughly 1 billion times more energy than the ticking it reported. 1 billion to 1, not for the time, but for the telling. As Vivek Wadia of the Oxford Group put it, the entropy produced by the amplification and measurement of a clock's ticks, long ignored in the literature, is the most important and fundamental thermodynamic cost of timekeeping at the quantum scale. Sit with what that means for tonight. In the emergent time picture, a clock does not reveal the flow. The correlating, the reading, the registering is the flow coming into being. And we now have a receipt showing that this act, the act by which moments are wrung out of the microscopic world, is 1 billion times more expensive than the microscopic events beneath it. Your sense that time is simply given to you, free, streaming past at no charge? Somewhere down in the machinery of every nerve and every instrument, something is paying, extravagantly, to manufacture each moment you spend. One more honest stone belongs in this wall before the night can climb to judgment. Even within the page-wootters program's successes, the Turin demonstration, a 2021 proof by Caterina Foti and collaborators that the mechanism reproduces classical dynamics too, Hamilton's equations and all, an old thorn remains, freshly confirmed in the technical literature as recently as this spring. Quantum mechanics still has no self-adjoint time observable. There is no operator for when, the way there is for position or energy, the time of arrival problem, unsolved since Pauli flagged it a century ago, persists inside every relational reconstruction. Whatever time is, fundamental river, thermal blur, or entangled correlation, physics cannot yet even phrase, when did that happen, as a native quantum question. The discipline that measures femtoseconds cannot define the thing it counts. Keep that thorn visible as we assemble the verdict. Intellectual honesty is the price of the view from up here. Look around your own life at how deep the clock web already runs. Because the relational picture is easier to believe than you might think once you notice you have never met time, only clocks. Your phone does not receive time from the cosmos, it synchronizes to other clocks, servers disciplined by atomic fountains, cesium atoms counted in national laboratories, the whole planet's schedule resting on a consensus of oscillators checking one another. Your body is a federation of clocks, circadian chemistry, heartbeats, the slow tick of cellular repair, cross-calibrated against sunrises and appointments. When you say you know what time it is, what do you actually possess other than agreement among ticking things? Where, in the entire chain from cesium atom to wristwatch to heartbeat, does time itself enter, as opposed to one more clock? The relational physicist's point is that no one has ever exhibited such an entry point. Correlations among clocks are all anyone has ever measured. The river, if it exists, has only ever been reported to us by its buoys. What does it mean that the most precisely measured quantity in all of science, time, tracked to 18 decimal places, has never once been measured directly? Because now the pieces are all on the table, every theory, every experiment, every wound and every receipt this subject possesses. And one question remains before the reckoning. It is the question a patient viewer has been holding since the first minutes. Fine, the fundamental now may be missing or manufactured, but why does time have a direction? Even a blurred, emergent, relational time runs stubbornly one way. Memory behind, anticipation ahead, eggs scrambling, never gathering. If the substrate is a sculpture, why does every path across it point the same direction? Tonight's final act before the verdict belongs to that arrow, and to Rovelli's most radical suggestion of all, the one that turns the arrow too into a mirror. Because when you ask carefully where the one-wayness of time comes from, the mathematics gives an answer almost nobody wants. It may come from the same place the flow does, from the blur, from you. Start with the fact itself, stated so plainly it becomes strange again. You remember breakfast. You do not remember tomorrow. Every photograph in your home shows a scene older than the shutter click that made it. Not one shows next week. Causes sit before effects, never after. And every macroscopic process you have ever witnessed agrees on the direction. Cream disperses into coffee, buildings weather, stars burn down. The arrow of time is the most reliable regularity in your entire experience. And here is the scandal tonight has been saving. The fundamental laws do not contain it. Newton's mechanics, Maxwell's electromagnetism, quantum theory, general relativity. Run any of their equations backwards and you get another perfectly legal history. A film of two colliding particles is physics forwards and physics backwards. Nothing in the microscopic law stamps one direction true. The one-wayness that saturates your life is invisible at the bottom. So where does it enter? The 19th century's answer came from Ludwig Boltzmann, and it remains the spine of every modern discussion. Entropy. Count the microscopic arrangements, his formula engraves it, entropy as the logarithm of the number of ways, and you find that disordered configurations outnumber ordered ones by ratios that beggar language. The cream-dispersed coffee corresponds to astronomically more molecular arrangements than the cream-swirled one, so systems wander statistically and inexorably from the rare arrangements toward the common ones. Entropy rises not because a law commands it, but because arithmetic overwhelms everything else. That is the second law, and its explanatory power is real. But Boltzmann's own contemporaries caught the trapdoor in it, and the objection, Loschmidt's paradox, has never been dissolved, only relocated. If the underlying laws are direction blind, then the statistical argument works equally well in both directions. A mid-entropy state is overwhelmingly likely to be higher entropy a minute from now, and, by the same counting, overwhelmingly likely to have been higher entropy a minute ago. Statistics alone predicts an entropy valley at the present, rising toward both past and future. It cannot, by itself, explain a world where entropy climbs steadily out of a low past. To get our arrow, you must add an assumption the equations do not supply, that the universe began in a state of extraordinarily, absurdly low entropy, a cosmic initial condition of almost unimaginable specialness, imposed by hand at the beginning and explained by nothing within known physics. The entire one-way traffic of the cosmos, every memory, every cause, every aging face, coasts downhill from an unexplained perfect start. Ask a cosmologist why time has a direction, and the honest chain of whys ends, 3 steps down, at a shrug pointed at the first moment. Unless, and here is Rovelli's most vertiginous suggestion, the one that completes tonight's pattern, the specialness was never in the universe at all. In a pair of papers in 2014 and 2015, one of them titled as a bare question, "Is time's arrow perspectival?" Rovelli noticed where the entire entropy story quietly depends on a choice. Entropy is not an intrinsic property of a microstate. The exact microscopic configuration of the world has no entropy at all. It is one arrangement, fully specified, probability 1. Entropy only appears when you coarse grain, when you lump microstates into macrostates, declaring which differences you can see and which you cannot. Cream versus coffee is a macrostate distinction made by creatures with eyes like ours. The molecules themselves draw no such line. Change the coarse graining, change which observables define your blur, and the entropy of the very same history changes with it. And now the radical step. The channel has spent all night on the idea that the flow of time comes from the blur. Rovelli's conjecture extends it to the arrow. Perhaps the low entropy past is not a special feature of the universe's microstate, but a feature of the particular, peculiar way our subsystem couples to the rest, of which handful of variables a warm, small, survival-built creature happens to track. His published conjecture states it with complete generality. For any sufficiently rich system, in either direction of time, there exists some choice of macroscopic observables with respect to which that motion satisfies the second law. If that is right, the universe does not have one arrow. It has arrows the way a sculpture has silhouettes, one per angle of view. And physical subsystems like us find from the inside that relative to the variables we couple to, entropy climbs in one direction. And we call that direction the past to future, and we could not have called it anything else, because our memories are made of exactly those entropy gradients. Ask why the universe began so orderly, and this answer replies, perhaps it did not. Perhaps you are looking at an ordinary universe through an extraordinary keyhole, and the order is the keyhole's shape. Be scrupulously clear about the standing of this idea, because it is the most speculative claim in tonight's whole cathedral. It is a conjecture, motivated, partially formalized, published in serious venues, and unproven. Critics note that some choice of observables exists is far weaker than our observables had to arise, and that explaining why evolution equipped us with entropy-climbing variables may smuggle the arrow back in through biology. Rovelli himself flags it as a direction, not a result. But notice what it completes. Flow of time, from the blur, thermal time. Definite moments, from correlations, page-wootters. Direction of time, from the coarse graining, perspectival arrow. Piece by piece across this night, every temporal feature of reality has been reinterpreted, by one research program or another, as a feature of the observer's window rather than of the world. The current, the ticking, and now even the one-way sign, all potentially manufactured by the same act of not seeing everything. What does it mean that physics can construct your entire experience of time out of ignorance, and cannot yet construct it out of anything else? And before the courtroom empties, notice that this final idea reaches all the way into the most intimate room of the subject, your memory. Why can you summon a summer from decades ago, the specific light, a voice, the smell of cut grass, while tomorrow is a blank? The physical answer is that a memory is a record, and a record is an entropy gradient, a low entropy trace, patterned neurons, a photograph's ordered grains, formed by an interaction and then preserved, the way a footprint holds the shape of a boot. Records can only form pointing down the entropy slope. That is why every trace in the universe, from craters to memories, faces the same direction. But if the slope itself depends on the coarse graining, if the direction of down is partly a fact about our window, then the great vault of the past you carry, the whole felt architecture of memory behind and mystery ahead, inherits that dependence. Your autobiography is real. The question tonight leaves open is whether its one-way ordering is a property of the universe that hosted it, or a property of the kind of thing you are. Which would you rather it be? And with that, the evidence is closed. Two frozen foundations. One machine that mints flow from warmth, wounded three ways. One demonstrated mechanism that mints evolution from entanglement, thorn and all. Three rebellions insisting the river is real. One arrow hanging between an unexplained perfect beginning and a perspectival conjecture. A vacuum that warms the accelerating, a diamond that warms the finite, a clock that pays 1,000,000,000 to 1 for its own telling, and, threaded through everything, a second hand sweeping on your wall, unbothered right now, exactly as it swept when the night began. Every court needs a verdict. Here is the honest one, weighed the way this channel always weighs, by what the evidence can actually carry. Begin the weighing with the claim everyone shares, because it is easy to miss how much consensus hides under tonight's arguments. Every physicist in this story, Rovelli and Smolin, Cons and Ellis, Page and Gisin, agrees on the following. General relativity is generally covariant. No experiment has ever detected a universal present. The Wheeler-DeWitt equation, whatever its pathologies, contains no time variable. And the naive picture you woke up with this morning, one cosmic river of moments, flowing identically for everyone, everywhere, is dead. It has been dead, really, since 1905, when simultaneity fractured. Quantum gravity only buried it deeper. Nobody on any side of tonight's debate is defending the river you actually believed in. The live question is subtler and stranger. Given that the universal flowing now is gone from fundamental physics, is time demoted, real but emergent, manufactured by warmth or entanglement, or is physics itself incomplete, missing a fundamental time it will someday be forced to restore? Three families of answers stood before you tonight. Weigh each at its true weight. The thermal time hypothesis. In its favor, it is built on rigorous theorem-grade mathematics, tomita-takesaki, KMS, the co-cycle theorem, not on metaphor. It needs no new physics, only a reinterpretation of structures already present in any quantum theory. It recovers the standard cosmological time of our universe from the actual thermal state of the actual sky. And it explains the 80-year-old Tolman-Ehrenfest oddity. Heat has weight, equilibrium tilts in gravity, in a single step with no additional assumptions. Against it, the circularity charge at its root. That equilibrium may quietly presuppose the very dynamics it claims to generate. Its silence on genuinely non-equilibrium states, which is to say, on most of the real universe. And Swanson's result that at the scale of an actual finite observer, thermal time and the time of watches and heartbeats fail to converge. Its standing, stated without varnish, a minority research program, mathematically deep, physically suggestive, explanatorily incomplete, and alive. The page-wootters mechanism. In its favor, it is the only proposal in tonight's story that has been demonstrated, a static entangled system exhibiting genuine internal evolution on an optical table in Turin. It reproduces the Schrödinger equation exactly for internal observers, and, by the 2021 result, classical mechanics too. And it requires nothing exotic, only entanglement, the most experimentally certified resource in quantum physics. Against it, the demonstration shows consistency, not truth. 2 photons in a laboratory do not tell you what the cosmos is. The old quantization ambiguities took decades to patch. And the time of arrival thorn, no self-adjoint time observable, still stands in its foundations, as fresh papers concede. Standing, an active and growing program, the closest thing emergent time has to a laboratory wing. The real-time rebellions. In their favor, they take the single most robust datum any human possesses, the vivid, structured, universal experience of passage, as evidence rather than embarrassment. Smolin's cosmological fallacy charge lands a real methodological blow that timeless physics has answered with practice rather than proof. Ellis's growing block honors the felt asymmetry between a fixed past and an open future that pure block thinking struggles to even state. And Gisin's information argument exposes a genuine unexamined assumption, infinite precision real numbers, buried under classical determinism. Against them, none has produced a confirmed novel prediction. The block universe reading of relativity remains the cleanest fit to the equations we possess. And reviewers across the spectrum, including physicists sympathetic to the instinct, judge the key steps philosophical rather than empirical, motivated readings rather than forced ones. Standing, a contested minority, carried by physicists of the first rank, kept alive less by data than by the sheer stubbornness of the thing it defends, which is, after all, every moment you have ever lived.
And the referee's card, honestly filled, no experiment currently distinguishes any of them. Not one. The timeless programs and the real-time programs are, as of tonight, empirically identical. Every measurement ever made is compatible with all three families. A New Scientist survey this January put the state of the art in one dry clause. The emergent time program has yet to produce anything testable that would separate it from its rivals. That sentence should be tattooed on every confident pronouncement about the reality or unreality of time, including, especially, the confident pronouncements in this video's title. And understand what empirically identical means at the level of your own life. There is no observation you could make tomorrow, no clock you could watch, no experiment you could fund, no journey you could take at any speed. Nothing would tell you whether you spent today inside a flowing universe or a static one. The two worlds do not merely look similar. As of tonight, they are observationally indistinguishable in every particular, down to the last measured decimal. You will live this week either way. The physics is identical. Only the meaning hangs in the balance, which is, of course, why the question refuses to die. When the evidence cannot split the candidates, the honest verdict is not a winner. It is a precise statement of what has and has not been established. So here is that statement, in two careful sentences, the two this entire night was built to earn. It is established, as firmly as anything at the frontier can be, that time is not needed at the foundation. Our best candidate equations for the universe function without a fundamental flowing time, and mechanisms exist, rigorous, partially demonstrated, by which everything temporal about your world could be generated from a timeless substrate by warmth, entanglement, and coarse blur. It is not established that this is what reality actually does. No observation yet rules out that time is fundamental after all, and the flow you feel is exactly what it seems, a feature of the world, not of the window. Notice how far even the cautious half of that verdict carries you though, because the weaker claim is not weak. For all of scientific history until this century, time might not be fundamental was a proposition you could not even formulate inside physics. The T was load-bearing in every equation, unquestionable because unremovable. What the last 60 years have shown is that it is removable, that you can take time out of the foundation and the mathematics does not collapse. It reorganizes and offers to hand time back to you as a product. Whether reality accepts the offer is unknown. That the offer exists, coherent, calculable, consistent with every experiment ever performed, is one of the deepest shifts in the scientific picture of the world since the quantum itself. The river is optional. Physics has actually drawn the riverless map, and the map works. What remains unknown is only whether it is the map of here. Why has no experiment split the candidates? Not for lack of trying, for lack of reach. Look honestly at where every decisive signal in this subject lives, because the geography of our ignorance is itself part of tonight's answer. The frozen substrate, the spin networks, the quantized areas, inhabits the Planck scale, 10 to the minus 35 meters, 10 to the minus 44 seconds. The most powerful accelerator humanity has ever built probes distances 1,000,000 billion times too coarse. No conceivable improvement of current technology, not a collider the size of the solar system, closes that gap directly. The Unruh warmth that would confirm the heat-time identity in the laboratory demands 10 to the 20th meters per second squared for a single Kelvin. The Hawking glow that would confirm it in the sky runs 2 billionths of a degree for a stellar black hole, buried a billionfold beneath the microwave background. The thermal time of the cosmos itself ticks at 2.7 Kelvin, a signal that has passed through your body every second of your life without your nervous system registering one quantum of it. Every confirmed piece of the timeless picture lives comfortably inside the mathematics. Every decisive test lives comfortably outside the reachable universe. That is not a conspiracy. It is the standard tragedy of quantum gravity, The scale where the answers live is the scale nature priced beyond every budget. And where the theory does touch measurable numbers, tonight owes you the caching of an asterisk planted 2 hours ago. The Barbero-Emerzi parameter, loop quantum gravity's one free dial, tuned to roughly 0.2375 so that the theory's count of black hole horizon states lands exactly on the Bekenstein-Hawking entropy. Here is the asterisk, in full. That value is not predicted. It is fitted. Worse, the fitted value depends on technical choices in how the counting is done. Competing published analyses have yielded 0.274 and other candidate values from different counting schemes. A transcendental number fixed by state counting conventions rather than derived from first principles. Fitting one constant to one benchmark is honorable physics. Planck fixed his own constant the same way. But it means the theory's flagship quantitative success carries a tuned bolt at its center, and physicists inside and outside the program say so plainly. The honest scoreboard of the timeless substrate reads 0 direct observations, 1 benchmark matched with 1 adjustable constant, a mathematical architecture of genuine depth, and a hard ceiling set by the Planck scale on how much better that scoreboard can get with any instrument now imaginable. So, could anything actually settle tonight's question? Ever? Yes. Be precise about what it would take, because the question deserves better than a shrug. The discovery that would end the debate is a discriminating prediction. Some measurable quantity, a correction to quantum interference at large masses, a signature in the primordial sky, a deviation in how identical clocks at different temperatures or entanglement structures drift, for which emergent time frameworks and fundamental time frameworks demand different numbers. The moment such a prediction exists and an instrument can reach it, this subject leaves philosophy forever. Nothing of the kind exists tonight. The programs are not yet mature enough to disagree about an observable, which is the precise, unglamorous reason the question of whether time flows remains, as of this evening, open at the foundation. There are hints of paths. Collapse model tests already constrain some real-time proposals from the side. Quantum clock thermodynamics, the billion-to-one budget from Oxford, has begun measuring the cost side of the emergent picture. Tabletop experiments probing whether gravity can exist in superposition would, if realized, drag the timeless substrate one step toward the bench. Paths, not verdicts. The frontier is real, and it is moving, slowly, at the pace of decades, toward the one question underneath all of this. Hold the scale of the hiddenness in your hands one last time, because numbers this size deserve to be felt rather than filed. If the frozen substrate is real, then between your thumb and forefinger, right now, sit more threads of the spin network than there are atoms in a billion Earths. And in the second it took to hear this sentence, that pinch of space hosted 10 to the 43 of its fundamental Planck ticks, each one 43 orders of magnitude below your notice. You live, in other words, at an altitude above the foundation so great that the entire question of tonight, does the floor flow or stand still, cannot even in principle be settled by looking down. The blur is not a temporary limitation of instruments. At those depths, the blur is structural, likely permanent, woven into what kind of thing an observer is. What does it mean to be a creature whose deepest question about reality is hidden beneath the very coarseness that, if tonight's hypothesis is right, makes the creature possible at all? Perhaps this, that the mystery of time is not an unfinished chapter of physics, but a mirror. Every attempt to look all the way down returns, at last, a portrait of the looker. Which leaves the ultimate edge, the one even a perfect experiment might not touch. Suppose the timeless programs win. Suppose some future test confirms that time is manufactured from warmth and correlation, exactly as tonight's machinery describes. A final why would remain standing, untouched, at the bottom of the stack. Why is the substrate such that its blur flows? Why does the bare algebra of the world's observables come equipped, canonically, unavoidably, as cons proved,
with that intrinsic one-parameter motion, waiting to be experienced as passage by any finite window that opens onto it. Physics can show that structure this rich cannot help but flow when viewed partially. It cannot say why there is structure this rich. And the reverse victory leaves a mirror mystery. If time is fundamental after all, physics inherits the question of what it even means for the deepest layer of reality to flow. Flow with respect to what? Either way, the night ends. The last question is not which theory of time is true. It is why there is anything for time, real or manufactured, to happen to at all. That question does not resolve tonight, and this channel will not pretend otherwise, in either direction. It stays open. It may stay open forever. Some edges are not cliffs to be crossed, but horizons. They move when you do. So return, one last time, to the belief you walked in with, because you did walk in with one, and it deserves a precise farewell. Time flows. A universal current, one moving now, the same for you and the farthest galaxy, converting future into past at 1 second per second. Tonight did not disprove that belief. Hold the precision because the precision is the takeaway. What tonight established is that the belief has lost its status. It used to be a background certainty, beneath question, the water every physical theory swam in. It is now a hypothesis, one candidate among several, contested by rigorous alternatives, favored by direct experience, favored by no experiment, and absent from the deepest equations we have. The current you feel between this word and the next may be a fundamental feature of reality. It may be a thermal artifact of your own blur. It may be a lattice of correlations wearing the costume of a river. As of tonight, nobody on Earth knows which. And for the first time in the history of physics, that sentence is not a confession of confusion, but a map of a real frontier, with real mathematics on every road.
And the beautiful, maddening part is how little your life lets you act on any of it. Tomorrow morning, your alarm will ring. You will be late for something, or early. You will wait for water to boil and feel the weight. You will remember yesterday and not tomorrow with perfect reliability. Every practical hour of your existence will proceed exactly as if the river were real. Because whatever time is at the foundation, at your scale it is locked in, as inescapable as the ground. Here is the one thing tonight may genuinely change, and it is not a schedule. The texture of a particular kind of moment. Some evening, maybe this one, you will glance at a clock and catch the second hand mid-sweep, and for 2 or 3 beats, you will actually watch it move. In that small window, you now know what you are possibly looking at. Possibly, a needle registering the current of the cosmos exactly as it appears. And possibly, the most sophisticated illusion ever manufactured. A warm creature's coarse-grained rendering of a world that does not move. Each apparent tick purchased somewhere down in the machinery at 1 billion times its face value. The whole sweeping show generated by the one thing you cannot do, which is see everything. The clock will not tell you which. Nothing currently can. That double exposure, the ordinary object and the open abyss behind it, visible in the same glance, is what a real frontier feels like when it runs through a kitchen. There is one place the frontier touches gently that deserves naming before the stones are gathered. The private one. Everyone carries moments they would revisit and moments they brace against. The conversation that cannot be rerun, the future that cannot be hurried into view. Notice how completely the entire emotional weight of a human life presupposes an answer to tonight's question. Regret assumes the past is closed. Hope assumes the future is open. Grief assumes that what has passed is gone rather than merely elsewhere. If the block universe readings are right, every moment you have ever grieved still exists. Not retrievable, not relivable, but real, holding its place in the whole. No more erased by your moving on then a page is erased by turning it. If the rebels are right, the openness of tomorrow is not a feeling but a fact, the digits genuinely unwritten. Physics cannot yet tell you which comfort is the true one, but it is worth knowing that both of them are, tonight, live possibilities in the equations, that neither the permanence of what you loved nor the openness of what you await has been ruled out by anything humanity has measured. Few sciences leave both doors of a heart standing open. This one, for now, does. Gather the night stones because you have carried more than most physics degrees cover. An equation of everything with no time in it, h hap psi equals 0, cursed by its own discoverer, defended by its own arithmetic. A floor beneath space made of frozen webs, 10 to the 68 threads through a single page, where the concept of later has no fundamental meaning. A formula for warmth, ρ equals e to the minus beta h. That turned out to be a formula for flow, once a physicist and a mathematician had the nerve to read it backwards. A theorem that mints a conveyor belt from any statistical blur, and a universe-sized receipt. The 2.7 Kelvin sky, generating, on this reading, the very cosmological time it appears to inhabit. A vacuum that warms for the accelerating at 24 billion trillion gravities per degree, and warms, faintly, unmeasurably, poignantly, for anything that is born and dies. 2 photons in Turin, static from outside, evolving from within, dissolving an ancient dichotomy on a tabletop. A quantum clock in Oxford paying 1,000,000,000 to 1 for the privilege of being read. 3 rebellions, method, experience, and mathematics, holding the door open for a river that every instinct swears is there. And 1 referee's card, blank where the decision should be, waiting on a prediction no theory has yet been able to write down. The refrain this channel returns to, one final time, because tonight it is not rhetorical. What does it mean? It means the most familiar thing in your life is officially stranger than the strangest thing in physics. Black holes, entanglement, the quantum vacuum, those are exotic, but their status is settled science. The passage of time, the thing you are doing right now, effortlessly, just by listening, is the one everyday experience whose fundamental reality physics can neither confirm nor deny. You are, in the most literal sense available to science, having an unexplained experience at every moment of your existence. Rovelli's question deserves to be the one that follows you out of tonight, spoken as he wrote it. Is it really possible that a perception so vivid, so basic, so existential, my perception of the passage of time, depends on the fact that I cannot apprehend the world in all of its minute detail? Notice that the question cuts both ways and was built to. If the answer is yes, then the flow is the signature of your finitude, the warmth of the diamond, the hum of the blur, and every passing second is, quietly, a measurement of how much world you cannot see. If the answer is no, then somewhere beneath the deepest equations there runs a current physics has not yet learned to write, and the vividness was testimony all along. Either answer would be among the great discoveries in the history of thought. One of them is true tonight, unclaimed, waiting. If these long expeditions to the edge of what is known are something you value, consider subscribing. It helps these deep dives reach more curious minds, and the frontier is not running out of nights like this one. The second hand is still sweeping. Look at it once more, properly, the way you never had a reason to before. Behind that thin, moving needle stands everything tonight assembled. The frozen equations, the woven floor of space, the warmth that may be doing all of this, the finite window with your name on it. The hand sweeps on regardless, serene, spending its 1,000,000,000 to 1 moments as if they were free. Perhaps it is measuring the deepest current in reality. Perhaps it is the sound of your own blur, ticking. Physics, tonight, cannot tell you which, and so the hand simply keeps its appointment, around and around, carrying the one message every theory in this story countersigns. Whatever time turns out to be, yours is passing. Spend it on wonder when you can. If the quiet hypothesis at the center of tonight is right, then the world itself never moves, and the movement you feel, all of it, Every sweeping second of it is you.